3C problem-solving tool is a lean or Kaizen framework designed to address operational inefficiencies quickly by encouraging root cause analysis rather than quick fix. It transforms messy, persistent issues into structured, solved, and monitored. In this video, we are going to see about why we should use 3C. Detailed explanation about 3C and its step-by-step process. 3C's application and when not to use. Let's get started.
Why we use 3C as a problem-solving tool in Lean or Kaizen framework. Speed. It is a lightweight tool for small, operational issues that don't need a massive Six Sigma DMAIC project. Prevents recurrence. By forcing a cause analysis, it ensures you aren't just putting a band-aid on a problem but actually fixing the root of it. Engages the team. It empowers shop floor workers to identify and fix their own bottlenecks immediately. Okay, let's see what are the 3C. Step 1. Concern. In this step, we find the problem. Step 2. Cause. In this, we investigate the problem. Step 3. Countermeasure. In this, we solve the problem. Concern. Its goal is to define the objective or define what is the problem to be solved. It can be defined using 4W1H rule. We can define the objective by asking, what happened? Where did it happen? When did it start? Who noticed it? And how many are affected? Gap analysis. Explicitly state the standard versus the actual. Example, the standard is 50 units per hour. The actual is 38 units per hour. Gap, 12 units per hour. The Gemba Check. You must physically go to the spot where the problem happened. If you didn't see the problem state with your own eyes, the data is just a rumor. This helps to avoid unnecessary analysis.
Cause. This is where you distinguish between a direct cause, I mean the immediate trigger, and the root cause, which is the systematic failure. The 5 whys chain. Ask chain of why question until the actual root cause is found. Don't stop at the first answer. Example. Direct cause, the motor overheated. But the root cause is, the maintenance schedule was ignored because the logbook was lost. Check for the point of occurrence and point of escape. Occurrence means why did the defect happen? Escape meant why did our current quality checks fail to catch it? Avoid human error. If the cause is, operator forgot, the real root cause is usually a lack of a visual standard or a poorly designed process.
Countermeasure. This is the only permanent fix. A true countermeasure is a process change, not just a be more careful reminder. We must do both countermeasure and containment. Containment is short-term solution, like wiping up a leak. But countermeasure is a long-term remedy, like replacing the seal with a high-heat version. Reevaluate. To prove the tool worked, you must remeasure the performance data from step 1. Example. Success metric. Output returned to 50 units per hour and has remained stable for 5 consecutive days. The final part is updating the standard operating procedure. A standard operating procedure is a set of detailed, written instructions aimed at achieving efficiency, quality, and uniformity in organizational operations. SOP is a step-by-step processes to ensure tasks are performed consistently, with reduced errors, and meet compliance standards. They are crucial in sectors like healthcare, manufacturing, and legal services. If the SOP isn't updated, the problem will eventually return. The 3C problem-solving tool is most effective for daily, short-term operational issues where the cause is relatively easy to identify. It is widely used across various industries as a first-level response to process deviations. Manufacturing and shop floor. This is the most common application, often integrated into daily management boards and SQCDP, safety, quality, cost, delivery, productivity, huddles. Example, production gaps. quality defects, and safety concerns.
Lean office environments. Use 3C to streamline information flow and reduce hidden waste. This helps in reduced processing delays, error reduction, and better procurement. In healthcare, it is used by frontline staff to improve patient safety and operational efficiency. When not to use, this 3C tool is not suitable for high-risk or extremely complex problems, like active health safety hazards or issues involving complex data trends.